Welcome back to Module 10. In this lesson, we're tackling a question that sits right at the heart of modern wireless networks. How do you actually manage access points at scale? We'll be looking at the two fundamental AP mode, autonomous and lightweight, and the protocol that ties everything together, CAPWAP, the tunnel that connects a lightweight AP to its wireless LAN controller. So let's start with the core problem. Configuring one or two access points by hand is no big deal, but picture a university campus with hundreds of them. Suddenly, you need every AP to broadcast the same SSIDs and enforce the same policies. You need clients to roam between them without dropping connections. You need radio channels and power levels tuned so neighboring APs don't interfere. And you need one central place to manage all of it. Doing that device by device just isn't realistic. And that's exactly why the controller-based model exists. That scaling problem leads us to two very different kinds of access points. An autonomous AP is self-contained. Every SSID, every security policy, every bit of configuration lives on the AP itself, which is fine when you've got one or two, but quickly becomes a nightmare at scale. A lightweight AP flips that model. The brains move into a wireless LAN controller, and the AP focuses purely on the radio side. That split, the controller handling decisions while the AP handles RF, is what Cisco calls the split MAC architecture, and it's the model the CCNA is built around. So let's look at exactly where that line gets drawn. Anything time-sensitive, beacons, acknowledgements, encryption, the actual transmission of frames has to stay on the AP because the radio simply can't wait for a round trip to the controller. Everything else, authentication, roaming decisions, RF tuning, policy, security, JAWI, gets pushed up to the WLC, where it can be managed centrally across every AP at once. Real-time work stays local. The thinking happens in one place. And the mechanism that actually carries that split is CAPWAP, the tunnel running between each lightweight AP and the controller. It uses two channels, UDP 5246 for control traffic, encrypted with DTLS, and UDP 5247 for the client data itself. Because everything is tunneled, the AP can sit on any subnet, anywhere in the network, and still behave as if it's plugged straight into the WLC. If you remember two numbers for the exam, make it 5246 and 5247. And that's AP modes and CAPWAP in a nutshell. The why, the how, and the port numbers to remember. In the next lesson, we'll zoom out and look at WLC architecture itself, where the controller sits in your network, the different deployment models, and how it all comes together. If this lesson helped, hit like, subscribe, and turn on notifications so you don't miss it. Full course is free on YouTube and over at Dargslan.com. See you in Lesson 4.